Good morning. So this is our 16th lecture. Today we will try to see some of the numerical problems on the vapor compression refrigeration systems through its different variants. So let us see problem number 1. If I read the problem number 1, it says that the condenser and evaporator temperature are 40 degrees Celsius and minus 40 degrees Celsius respectively for a two-stage ammonia refrigeration system of 10 tons of refrigeration cooling capacity. A water intercooler intercools the low pressure vapor to 40 degree Celsius, and further intercooling up to saturated state is done in a flash chamber. Okay, now we have to find the mass flow rates and work requirements of the compressors. So we have two-stage system, there will be two compressors, so we have to determine the mass flow rate and work requirements of two compressors. And condenser heat rejection, how much heat we have rejected in the condenser, COP of the system, and we have to compare the results with the triple S cycle. Triple S means standard single stage saturation cycle. Okay, so the question is, what are the key things given? Condenser temperature is given as 40 degrees Celsius, evaporator temperature is given as minus 40 degrees Celsius. It is mentioned in the condenser that two stage NH3 refrigeration system we have with 10 tons of refrigeration cooling capacity. It means refrigeration effect is equal to 10 tons of refrigeration. In this system, we are using a water intercooler which is cooling the liquid vapor to 40 degrees Celsius. We know that at the exit of the compressor, we will be having some superheated vapor. That vapor we pass through the water intercooler, and in the intercooler we are cooling it up to 40 degrees Celsius. It is mentioned in the question that further flash intercooling is done up to saturated vapor state. Is this point clear? So it means after water intercooler, there is flash intercooler where whatever is going at 40 degrees Celsius, that is actually again being cooled. Okay, and we need to determine the mass flow rates, as well as we also need to determine the work to the compressor and COP of the system and heat rejection in the condenser. And we also need to compare the COP if instead of two-stage cycle we use a single stage cycle. Okay. So can you tell me how its pH diagram will be looking like? What will be pH diagram for the given situation? Please tell me. This situation is of a flash chamber. Okay, two-stage system using flash chamber, and flash chamber is also being used as a intercooler. So if I have to draw the pH diagram, then what I need to do, pH, and this is my liquid vapor dome. So of course, first, how many pressures I will be having? I will be having two pressures. One will be corresponding to condenser temperature, other will be corresponding to evaporator temperature. So condenser temperature is 40 degrees Celsius. How to determine condenser pressure? Corresponding to 40 degrees Celsius, if I go to saturated property table, then whatever is the saturation pressure given over there, that will be nothing but my condenser pressure. Okay, so can you tell me how much is the condenser pressure corresponding to this condition? 1.55 MPa, correct. So PC is nothing but 1.55 megapascals. Okay, all are clear with this point? All of you have got the tables, ammonia table. And from the ammonia table, are you able to locate how you have calculated the pressure? Because this is important. This you should know from thermodynamics. In case someone is having difficulty, I am again repeating the process. Corresponding to 40 degrees Celsius, you have to refer to saturated property table and you have to determine the value of saturation pressure. Is this point clear? Then second is evaporator, which is at minus 40 degrees Celsius. So evaporator pressure will be nothing but equal to saturation pressure at minus 40 degrees Celsius. Okay. So again refer to minus 40 degrees Celsius. How much is pressure? 0.071. Yes. 0.0717 megapascals. If in bar, then 0.717 bar. Okay. All are clear with this point? So it means we have determined now condenser pressure and evaporator pressure. So let me draw two lines. This will be PC, this will be PE. Now I must have one more line which will be nothing but intermediate pressure. Now what will be the value of intermediate pressure, that let us try to calculate. Okay, but before that let me draw the process. So at the exit of evaporator I will be having state 1, then 1 to 2 I will be having compression. After 2 what I have? Water intercooler. So then I will be reaching to some point 3. Then what I have? Flash intercooler, and this flash intercooler is doing intercooling up to the saturation state. It means my point 4 will be here. Then at point 4 to 5 again I will be having compression process. Then 5 to 6 heat rejection in the condenser. 6 to 7 flash. We have flash chamber. So in the flash chamber we have to first do the expansion up to the intermediate pressure. After doing the expansion up to intermediate pressure, vapor will stay at the top, liquid will be there at the bottom, state 8, and from the bottom liquid again we will be doing expansion up to state 9. Anyone is having any doubt about this? Okay, so this cycle is very simple. Now the point of interest is we need to determine the intermediate pressure. Okay. Under the ideal conditions, we know that intermediate pressure can be simply given as geometric mean of PC and PP. Tell me how much is this value? Under ideal conditions, it will be nothing but the geometric mean of these two. Fine. How much is this value? Please do calculate. 0.3339 megapascals. Is this point clear? Now, usually my under ideal condition, usually my pressure should be this value. Okay, but it is given in the question, or if it is not even given, then also there is a usual practice that from the ideal pressure, whatever temperature I will be getting, okay, from the ideal condition corresponding to this Pi, I will be getting the value of some saturation temperature. Tell me how much is this saturation temperature corresponding to 0.3339 megapascals? Minus? No, it is not exact actually. Minus 6.5 degree Celsius. Correct. So corresponding to intermediate pressure, all of you please check your property tables also. You should be able to locate the value. If anyone is having doubt, someone is not able to locate, just ask the question. Because in the exam you have to individually do and calculate properties. Okay. So T saturation is minus 6.5 degree Celsius. There is a thumb rule that whenever we calculate intermediate pressure at the ideal condition, usually whatever temperature we get for the this condition from the ideal condition, In this temperature, so let me call this as Pi star and T star. In order to calculate the actual saturation temperature, we just add 5 degrees. Simply add 5 degrees. Okay, so whenever you need not to remember this thumb rule, if the same similar type of question comes in the exam, it will be specified in the question. Okay, so right now, based on the thumb rule, I am just telling you that we will be simply adding the 5 degrees. So it will become minus 1.5 degrees Celsius, correct? Now, if you refer to your property table, in property table you will be finding that 1.5 direct entry is not coming in the table, but 2 degrees Celsius entry is coming in the table. Okay, so for the sake of, it is not there, in my table it is there. Okay, in my table actually 2 is also there. So it means for the sake of avoiding the interpolation, I have approximated it nearly equal to 2 degrees Celsius. So that I can directly use the property table, I need not to perform any interpolation. Because whenever the direct value is not available, then what we do? We take one lower value, one higher value, closest, and then we do the linear interpolation. Okay. So to avoid the linear interpolation, because in my table 2 degrees Celsius is given, I am approximating this 1.5 degree to 2 degrees. Fine. Okay, now what will be my actual intermediate pressure, Pi? It will be nothing but P sat at temperature Ti. Because we are now going the reverse way.
So minus 2 over.
Sorry, minus 2 degrees Celsius. Yes. Is it correct? Okay, so now Pi will be what? Intermediate pressure. So intermediate temperature I have determined as minus 2 degrees Celsius. So this will be nothing but saturated temperature. So corresponding to saturated, whatever is the saturation pressure, that will be my intermediate pressure. Okay. So how much is Pi? Please tell me. 0. Correct. 0.3982. 0.3982 megapascals. So it means I know now the value of intermediate pressure. All of you are clear with this point? Now let us start the question. How we will be starting? We need to calculate the property value at different conditions. So let us start with point 1. What will be value of enthalpy at point 1? H1 is how much? How to calculate H1? I have temperature of minus 40 degrees Celsius. State 1 is a saturated vapor state. So corresponding to minus 40 degrees Celsius, from the saturation table I need to calculate Hg. How much? 1550.92. Okay, my table is having different value. Of course, whenever you will be referring to different refrigeration tables, you may find different values. Don't worry about that. Why different value comes? Because the reference state which different tables have used, that can be different. Whenever you will be referring to the steam table, in steam table always your property value will be same. Why? Because for steam table the medium is water, and for water reference state is always frozen, which is the triple point of the water. So corresponding to triple point of water, if you see the value of internal energy, you will be finding that internal energy value is 0 in the liquid state. Okay, but in case of refrigeration tables, because the boiling point is very low, so what usually people do, so different books, they use different reference state. Okay, so say someone has specified 0 value corresponding to minus 100 degrees Celsius, someone might have specified 0 corresponding to minus 150 degrees Celsius. So that's why the value will be changing. So don't worry about that, but what you need to do, whatever property table you are referring to, for all values of the problem you have to use the same table, because ultimately we are not interested in the absolute values of the properties, we are interested in the difference of the properties, because whenever you will be calculating refrigeration effect, work done, etc., it will be coming as H1 minus H9. So difference will always be same. So I am not writing my values. Please tell me what is your value. H1 is 1550 kilojoule per kg. Okay, so this is H1. I have some other value, it is 1387. Of course, it will not be exactly correct. So H1, similarly, I can also calculate the entropy S1. What will be S1? 6.714 kilojoule per kg Kelvin. Unit of entropy is kilojoule per kg Kelvin. Okay. Again, my entropy is also different, but we need not to worry about this. Okay. Then, what other properties I can easily determine? H2 you can easily determine.
S2.
Okay, yes. S1 will be equal to S2. Okay. Other than that, the property which you can determine easy are H4. What is H4? 1602.5 kilojoule per kg, and S4 is
6.12.
and it has to be equal to S5. Okay. Then H6 can you determine? H6. How much is H6? Please tell me quickly. 16?
33.06.
Wrong. It cannot be that much high.
533.7.
533. You got the point? It should be saturated liquid. And whatever is H6, same will be H7, because 6 to 7 is an isenthalpic process. Okay. Can you tell me what will be H8? Please quickly tell me. $330. Someone is doing interpolation. 334. Exact is 334. Which will be equal to H9. H8 will be equal to H9. All are clear up to this point? Anyone is having any doubt? Please tell me. All of you are able to locate from the table? Anyone who is not able to locate, we are moving very slow, so that with this question you can get practice of even your property tables as well. Okay. Now after this, can you tell me which property we can determine? From saturated table only these were the properties which we could determine. Now we need to calculate H2, H3. How to calculate, and H5. How to calculate H2, H3, H5? If you see from pH diagram itself, state 2, 3 and 5 are in the superheated state. So we have to refer to superheated tables. Okay. In the superheated tables, if you see, we always require how many number of state points? two state points to predict any property. Okay. So for state number 2, one value is my intermediate pressure, which is 0.3339 megapascals, and second value is entropy, which is 6.714 kilojoule per kg Kelvin. Okay. So if I can locate these 2 points, then I will be able to determine the value of enthalpy. So first point is, whenever you are going to superheated table, try to locate pressure of 0.3339 megapascals. Are you able to locate it? From superheated table. Got it? Now, in this, corresponding to this pressure, you have to see where value of entropy is close to 6.714. You will not be getting exact value, so you may need to interpolate. Pressure, are you getting exact? There also you need to do interpolation. So it means it will be a two-stage interpolation. How to perform two-stage interpolation, do you know? Do you know how to? Okay, quickly tell me, what is the nearest pressure available corresponding to 0.339 megapascals? What are the nearest pressures available?
300 and 400 kilopascal.
Sorry?
300.
400 kPa. Yes, 400 kPa, not megapascal. Okay, so one is 400 kilopascals, other is 300 kilopascal. First, what you need to do, now at 400 kilopascal and 300 kilopascal, go to this 6.714. Are you able to find it? Entropy value. Is it available or not? Not available. But there will be one value lower than 6.714, one will be higher than 6.1. So first tell me, from 400 kPa, what is the value lesser than 6.714?
6.68.
6.68. And higher?
6.75.
6.75. Corresponding to these, what are the enthalpy values? 6.68.
1776.
17.
76.12.
Okay. What is enthalpy over here?
1799.
17.16. Okay. Now what you need to do? You need to calculate enthalpy at this point. So enthalpy at 400 kPa is how much? Tell me.
1799.
Y2 minus Y1 divided by X2 minus X1 plus Y1. Okay. So how much it is? 0. Yeah, 39. Yes, correct. Okay, exactly you are saying, just take it 400 kPa. 1786. Calculated? Guess. Oh. 1787. Close calculation. So now he is saying that 0.39 is 390 and this is 400. So let us assume the value. Of course, you can make approximation while you are doing the question. At present, let us try to see how to apply two-stage interpolation. Okay. Because have you done in thermodynamics two-stage interpolation? Not done. So let's see over here then. So at 300 kPa, now tell me, what is the smallest value corresponding to 6.714. Nearest values. One smallest, one larger.
6.69.
6.69 and
6.76.
6.76. Tell me the values of enthalpy.
1734.67.
17.67. Other 1757.3. Calculate the enthalpy for the 6.714. All of you are able to follow?
300 kPa का concentrate
Superheated.
नहीं भाई superheated है.
Deepak, did you get the table?
Yes, yes.
See, practice numericals because it is required. In the exam, you have to do this independently. Okay, tell me the value. Deepak, calculation.
I'm locating the Google.
1739.81.
1739.81. Correct. Now, you see, entropy value you have already frozen in both the cases. Okay, because we have calculated corresponding to the actual entropy value. Now, only thing is we need to go to the correct value of pressure. So now you can see this is the enthalpy at 400 kPa. This is the enthalpy at 300 kPa. You need to calculate enthalpy at 398. It was close to 400. But okay, you have come to know the two-stage interpolation. So 398 kPa. Calculate. But also see that you have this much large range. So there will be small difference. How to do interpolation now? You know three pressures. Enthalpies are known only at 2. So you need to calculate enthalpy at now third pressure. So this is how you have to apply the interpolation in two stages. Okay.
1785.
1785. So it means that after doing so much of process, of course in this case you need not to do, you could have directly taken the value corresponding to 400 kPa, but whenever you may have some value, say 350, then also it is very simple to do average, but at least for 350 you need to perform these two steps. Then final interpolation step will be simply arithmetic. Okay. So this is enthalpy of which point? 2 point. So enthalpy of point 2 is 1785 kilojoule per kg. Now you tell me how to calculate enthalpy of point 3. How to calculate enthalpy of point 3? At point 3 we know two things. One is pressure, intermediate pressure, and second thing is given in the question that water intercooler is doing intercooling up to 40 degrees Celsius. It means temperature at point 3 is 40 degrees Celsius. Okay, so temperature of point 3 is 40 degrees Celsius. Now again go to superheated tables. You have to locate 40 degrees Celsius and pressure of 400 kPa. Let us go with now 400 kPa.
432.4.
H 1706, correct. If your value is correct or not, you can check with H4. What was your H4?
Greater than
H4 is less than 70.
H4 is 1602.
Yes.
So it is greater. It means it's correct. Okay. So it should be in between 2 and 4. Okay. Now what is left? H5. Only one enthalpy is left. How to calculate H5? You know the condenser pressure? Do you know condenser pressure? How much it is?
1.55
1.55 MPa. Okay. So do you have 1505 kilopascals?
150. 150.
This is 1.5.
1600
It is not there. 1600. One is 1600 and other is 1400. And other property, what do you know? And you have to calculate at 1555. Okay. Other property, what do you know? S4 is S5. So how much is S5? 6.12. Now you see what are the closest value up to 6.12. Please do it fast. We have spent almost 40 minutes. We will not be able to do only a single problem. I thought we will do 4 numerical problems.
1806. 1806.
18.0 at 6.12. Oh, directly 6.12 is there. Good. 1806 point, and at 1400 6.12 is there. It is not there. Then one smaller, one larger. Closest, smallest end.
6.1.
ठीक है. Consider it.
1643.
1643. Okay.
0.2. अच्छा
1787.
1787.5.
Point.
1787.59.
Now you can calculate. Tell me, what should be H5? So all enthalpies you have calculated. If you are getting wrong answer, then it is not my responsibility. What is H5? Tell me. 1796. Calculated or just? Those who are calculating, please tell me. So it means that I need to give more number of questions to you people, those who are not using calculators in the exam.
1802.57.
1802.57.
Not possible, sir.
1802.17.
सर 100 में 18 का व्यापार अराउंड तो 55 25 का आता यहाँ से है ना 1806 और 1787 के बीच में तो 10 के नंबर आएगा
They have calculated, many of them are getting.
Who else?
You have calculated?
Yes sir 1802.17
3 people have calculated. There,
sir but सर 100 के बीच में 18 19 का डिफरेंस आ रहा है तो 55 के अराउंड 9 का आना चाहिए ना
1806 and 1787. You are wrong. It will be close to this one only. Na? You see, 155. Okay, it is 155. Your calculation is not Correct. Okay. So we have got all the enthalpy values. Once we got all the enthalpy values, can we determine mass flow rate? What will be the mass flow rate handled by the low stage compressor? M dot 1 will be equal to refrigeration effect divided by H1 minus H9. It is 10 tons of refrigeration. 10 into 3.51 kilowatt. Okay. Divided by H1 is how much? Calculate H1 minus H9. Give me direct value of mass flow rate. Let me now check whether you have calculated correct enthalpies or not. How much is mass flow rate? Please do it fast. All of you should do it. You are not even writing anything. See it. 0.0288. Yes, my answer is 0.02893 kg per second. So it means you have calculated correct enthalpies. Okay, how to calculate MHP? This is MLP. How to calculate MHP? Please tell me. What will be mass of high stage compressor? What was the relation? Do you remember? M dot HP is equal to M dot LP into go here. This is the flash chamber. In the flash chamber, if I apply the mass balance, so M dot 2 mass is going with enthalpy 4. It is entering with enthalpy 6. 6 and 7 both are same. Okay, so it is entering with enthalpy 6. So it means M dot 2 into H4 minus H6 has to be equal to low pressure fluid is coming at M dot 1 mass with enthalpy H3 and leaving with enthalpy. Okay, so try to calculate. Or even what you can do, because my numbering is same, so refer to your notes and see what relation I have given in between MHP and MLP. What was the relation? Refer to correct diagram. Flash intercooler, flash chamber and water intercooler. Please tell me. M dot HP is equal to M dot LP H3 minus H8 divided by H4 minus H6. Okay. Same thing, na? So now calculate. How much is M dot HP? Please do it fast. You have taken almost 1 hour. Now you should be able to, you should do it fast. How much is M dot HP? 0.0. My answer is 37. Yes, 37 kg per second. Okay. Now can you calculate the compressor work? Very easy. What is the compressor work?
First compressor gave 234.
First compressor 234.
Second clear 199.67.
What is unit?
Kilojoule per kg.
Huh? Kilojoule per kg. You should multiply with mass per rate. You have now 1 or 2 mass per rate also, na? So make it kilowatt. Okay, what are the works? You simply need to multiply LP and MHP. Very slow you are doing actually. Very simple. MLP into H2 minus H1 and MHP into H5 minus H4. Why it is taking so much of time?
8.18.
8.18 kilowatt is LP, and what about HP? Do it fast, but values are not matching. My value is different. It is not 8.18. Someone else? How much is HP? 7 point?
6.76.
6 point? Slightly different. Someone else? Please do verify. Because as per my answer, LP is 6.79, HP is 7.36.
7.4.
7.4, correct. HP. So your answer is correct, incorrect. So 7.4 is HP and LP. LP is how much? 6.74, correct. Now it is correct. 6 point mine is 6.78. even 6.79. Okay. Anyone else got it?
W1 वाला 6.74.
Okay. What will be COP? 10 tons of refrigeration, 10 into 3.51 divided by 6.79 plus 7.4. How much it is? Why you are so much slow in calculator? You should be very quick. Sorry? Yes, 2.48. And heat rejected in the condenser is m dot HP into H5 minus H6. You can calculate it now. Okay, I need not to ask you to. Now the next question is, if instead of this I operate a single cycle, single stage cycle, then what will happen? Standard cycle. So evaporator like this. 1, 2, 3, 4. H1 will be remaining same. Okay. What was the value? Quickly tell me.
15.9.
15.
50.
And H3 will become the previous H6. What is that value?
533.7.
533.79. Only thing you need to calculate is 0.2. Now 0.2 pressure is how much? EC.
1.5.
1. megapascals, and S1 is equal to S2. S1 you are already having. So how much is S2? 6.714. Okay. Now what you need to do? Interpolation to calculate H2. Do it fast. Tell me, quickly tell me, what is the value for H2? Tell me fast. How much is H2? You know 1400, you know 1600. Correspondingly, are you getting 6.714 there? No? Closest value is what? 6 point? Just take that enthalpy. H2 have you calculated? Final interpolation did you perform? You have to be quick. If you take more than 5 minutes in just calculating one state property, then how you will be able to do 5 to 7 questions in 3 hours?
So close to 2037.
Okay.
H2 given.
Final value. Okay. 20 37 kilojoule per kg. Now, what will be COP? Okay, what will be first mass flow rate? Mass flow rate over here will be 10 into 3.51 divided by H1 minus H4. And if you do calculate this, it should be how much? 0.0
0.064.
3462. Yes, 3462 kilogram per second. Okay, and now how much will be COP? Simply H1 minus H4 divided by H2 minus H1, because mass flow rate will be same. So how much will be COP? Tell me quickly. It will be 2.05. Okay, and if you calculate compressor work will be 17.16 kilowatt. Fine. So you can see that if you use a single stage cycle, your COP was 2 and compressor work was 17. But when you use the multi-stage cycle, COP became 2.48 and compressor work was 6 plus 7, somewhere close to 14. Okay, so it means there is saving in compressor work and increase in COP upon using the intercooler. Now, this is a homework question to you. In the exactly same question what we have done, where condenser is at 40 degree, evaporator is at minus 40, intermediate state is corresponding to 2 degrees, minus 2 degrees Celsius. Okay, corresponding to minus 2 degree Celsius. Instead of flash chamber, instead of flash chamber, now we are using liquid subcooler. Got my point? Instead of flash chamber, we are using liquid subcooler, and liquid is being subcooled from 40 degrees Celsius to 5 degrees Celsius. Whereas the other things remain same. We have water intercooler which is bringing up to 40 degrees Celsius. We have then flash intercooler which is bringing to saturated state. But now we are not using flash chamber. It means we are not taking out the saturated liquid, but we are subcooling it from 40 to 5 degrees Celsius. So if I use flash chamber as a liquid subcooler, then what will be my mass flow rates of low pressure and high pressure compressor, work done, COP of the system, and heat rejected in the condenser. Calculate this, because now with this you can compare the relative performance of the subcooler and the flash chamber. Okay, calculate this COP also. Got my point? So this is a homework question. The previous statement remains the same. Only addition is that now we are not using flash chamber, but we are using liquid subcooler, and it is subcooled from 40 degrees Celsius to 5 degrees Celsius. You have to tell me the four values: mass flow rates, work done, COP, and heat rejected in the condenser, so that we can compare in the next lecture. And in the next lecture we will do two more problems, one on multi evaporator system, one on cascade system.